Hello everyone and welcome to the next in our beginners tutorial series. In the last lesson we covered how to put a sprite onto your ROM and then how to display that sprite on the screen, but Sonic in that example was looking a little bit stiff, he wasn't moving too much, so today I want to teach you how to animate the sprites. We're going to pick up right where we left off last lesson. We're going to be using that same file where we put the sprite on the screen, but I have a download link in the video description. It will contain this animation sheet for Axel here from Streets of Rage 2. So if you have to do is copy that into the res folder, and as usual we're going to have to change it so that we're going to swap the Sonic sprite for this sprite. So we're going to change the name of the file, and then I'm going to save and compile here, but it's going to produce an error. I want to see if anyone can guess what the error is going to be and why. So let's try and do that now and see what kind of results we get. And I've located the error message here. So it says that the width 840 is not a multiple of the cell width 48. So what's the cell width and what does that mean? If you remember from the last lesson, the two 6s there just before fast were ones that we put to give the size of the sprite in tiles. So it was 6 tiles by 6 tiles, with each tile being 8 pixels in length. Now the Axel sprite we're using here is different in size from the Sonic sprite, which is why it's causing an error, and it's not just that the sprite itself is a different size, but the way we have to think about the animation sheets rather than just single sprites is a bit different. So let me demonstrate that here by taking a look at a sprite. When we create a sprite sheet, we save it as one single large PNG file, but when we input it into SGDK, we have to tell it how large each individual animation cell is. Now here, each square, grey square, background square represents 16 by 16 pixels. So for this Axel sprite sheet, it is 15 8x8 tiles wide and 16 8x8 tiles tall. You can probably guess by looking at the sheet here that each horizontal line represents a different animation, and we will come back to that a bit later, but for now let's head back to SGDK and let's input the correct values. So we're going to replace that 6x6, which was the size of the Sonic sprite, with the 15 by 16 size of each individual animation cell of our Axel sprite sheet. And now you can see here that it's compiled without any problem, so let's head back to the main.c file. Let's just run this now just to make sure that Axel is showing up okay, which he is right at the bottom there, but let's move him up a bit, move him up the screen a little bit. So let's change that 100 pixels where he's going to be put on the screen, and let's change it to 50. So if we then save and compile again, hopefully it'll move up the screen a little bit, and he's much more close to the center now, which is obviously a lot better. Okay, now that we are confident that we have successfully put our Axel sprite onto the ROM, the next thing is to animate it. So the animation function in SGDK is called spr_set_anim, and as soon as we open up the brackets, as usual, we'll get a nice little clue about what to put. The first parameter will be sprite. Now you can probably guess that we have to put our sprite name. If you used a different sprite name in the previous lesson, then obviously put that, but for me I called it player, so that's what I'm going to put here. And as usual, we'll do a comma to separate the two parameters, and the next one, it says animation index to set. Now this might require a bit more explanation. For now we're going to put it as 0, and then don't forget the semicolon as always, and we're going to take another little trip to a sprite just to see what this animation index actually means. All it refers to is which line of animation we're going to play. So as usual in computer program, we start from 0, which will be the top one, then 1 will be the idle animation, 2 the walking, and finally 3 the grand upper that I'm sure everyone's looking forward to. Since we have set the index in our function to 0, it's obviously just going to play that first one, which is no animation at all, it's just one single image, but if we change to 1, it should play the idle animation. Or maybe not. Now, can anyone guess what the error is? To give everyone a clue, it's actually located in our resources.res file. Some of you may remember from the previous lesson that the final value we put in when we uploaded our sprite onto the ROM was the animation speed. Now it's set to 0 right now, which is why it's not moving at all, but if we set it to 60 for example, that means every 60 cycles of the computer is going to change the animation one time. And since there are 60 frames each second, it means it's going to change once every second. I think you'd all agree that our boy Axel here is moving a little bit too slowly, so let's get that changed to a faster animation speed. If we were to change it to 10 for example, that means it's going to change 6 times every second, and if we save, compile and run, this is what it's going to look like. Maybe a little too fast now. This sprite sheet is something I threw together quickly myself, so I'm not 100% sure that I got the sprite sheet accurate to the original's animations, but I don't think it looks too bad, and feel free to experiment to your heart's content and change the speeds until you get one you're satisfied with. So I think maybe 15 is kind of quite similar, maybe a bit too slow, maybe 20 was the correct one, but feel free to have a play about. But for now, let's change the animation. So one was walking, and if we want one was idle. If we want to go to walking, we have to change it to 2, and if we save and compile, we should get the walking animation, which definitely looks a little bit too slow at that speed. Let's just give another figure a try, so change it to 8, so it's almost twice as fast, and see what that looks like. And so now probably a little bit too fast, but as with last time, just experiment and play around with it and see if you can get something that's accurate to the original. Okay, now let's get to the animation I think everyone's been looking forward to, the legendary grand uppercut. And if we now save, compile and run, it doesn't actually look too bad. I think it looks pretty good. Maybe it can be a little bit faster, but you gotta love that animation. It's a classic. Even just watching it without sound, you can still just about hear the At the moment, we're simply putting in whichever number we want, but in programming that's known as hard coding numbers, which is always frowned upon because especially as the code gets bigger and bigger, it becomes more and more difficult to handle. We have a lot to change. So just like in previous lessons, we can create a variable. So we can create an integer, call it anim, and make it equal to 3. Now instead of hard coding 3 in there, we can simply put 3 in here, and we can just change the variable whenever we want. So if we compile again, save and compile, it gives our grand upper as usual. So we've changed that to a variable now. As our game gets bigger and bigger, it might be difficult to remember which animation goes with which index number. So for example, you might not always remember the index for grand upper is 3. So that's why instead of using the number 3, we can give it a name. But actually we don't need a variable for this. What we need is a constant, because after all, grand upper in a sprite sheet is always going to be 3. It's not going to change. So a variable isn't suitable here. Now to create a constant in C, we can use the const word at the beginning. And as a convention, constants are always written in uppercase letters. So when we see them in our code, we know that we're not going to be able to change them. You can't add 1 or take away 1 or multiply these numbers. Now that's great, there's now uppercase, but anim is a bit vague, so let's make it clear that this is going to be the grand upper animation. So let's add an underscore and write upper. So now instead of having to remember that grand upper is 3 index number 3, we can simply write anim grand upper wherever we want to use it in our code, and that way we don't have to remember which index number goes with which animation, so it's much more convenient for us. Although it's great that we now have this const new data type that I've just taught you, so we can ensure that this 3, we're not going to do anything stupid in our code like change this 3 to, I don't know, 27 and mess up our animations. Actually, even though I've only just introduced this new concept to you, I'm going to take it away because we're going to use something else instead. Now, this const word here, this type of constant, we're going to be using a lot in SGDK later on in order to manage the RAM. So the Mega Drive doesn't have too much RAM. So managing that RAM, what goes in and out, is very important. But for now, we're going to change this to something else called define. The syntax for define is a bit different from declaring a regular variable or a constant. So we have hashtag define, we don't need the equal sign, and we don't need a semicolon. So it's a bit unusual in that way. Now, if you're wondering what's the difference between define and using const, for our purposes here, just both think of those as constants. Now, there's a big debate. You can look it online, you can Google it, what's the difference between a constant hashtag define in C, and you can see lots of debates about what's going on. But for now, just know that when we're defining like animation, we're always going to use this define word instead of the const, and it's also going to be used when we do sound effects later on. So we've already got our define for a grand upper, and now we're just going to do the rest. So the first animation, remember the first line was that just the single one, and then the next one, number 1, was the idle animation, and then the third one, which obviously be number 2 because we start counting from 0, will be the walking animation. So instead of having to remember which index goes with which animation, we can simply type, anim idle, anim walk, and so we don't have to remember that anim walk is 2, for example. And plus being constants, it means we don't have to worry about accidentally changing these values in our code, which actually can happen. Now if we save and compile just to make sure everything's working as it should, so you can see that even though we just wrote grand upper in the SPR set anim function, it recognized that was the third index, and that works fine. And if we want to change that to anim walk, we can simply change it to anim walk here instead of having to remember, oh yeah, which index is that? Is it number 2? Is it number 1? So as you can see here, it's now doing the walk, so it works like a variable, but obviously it can't vary. This is set, so we couldn't add, we couldn't change this anim walk, so that's good for our purposes because we don't want it to change, we want it to stay the same. Okay, that's it for this lesson. I hope everyone has fun animating Axel and maybe playing about with the animation speed, and you can mess about with some other settings too. In the next lesson, I'll teach you how to create your own sprite animations in Sprite, and also how to create your own sprite sheets so that they're suitable for importation into the Mega Drive. And lots of people have asked if I could do a lesson on how to take assets from other games, for example a Super Nintendo game, and how to port them to the Mega Drive in a way the SGDK and the system can understand and use. That's it for this lesson. Thank you so much for watching. If you're interested in this kind of content, then please subscribe to the channel.
I'm interested in this.
And if you want to support the channel further, I have a Patreon account.
You won't go unrewarded.
And until next time,
farewell.